Essentially, the James Webb Telescope provided the most precise image of Proxima B in history, revealing breathtaking snippets of knowledge about what might be an exoplanet. It supports us as we embark on an exploration of space in search of Proxima B's secrets and whether it might be the next Earth. We ought to launch out into the vastness of space, where an unidentified planet exists in the star's habitable zone. This planet is much more than just an ordinary rock. Proxima B, discovered just 4.2 light-years away from us, holds many mysteries. Scientists wonder whether it could be another Earth with seas and life that grows there. However, there is more to the Proxima system. Proxima B isn't the only planet. It has a companion, Proxima Centauri C, orbiting the red dwarf star. Who knows what other mysteries the star system holds? There might even be another companion that we haven't found yet. The secret continues with Proxima. The amount of energy produced by Proxima Centauri is roughly the same as Earth receives from the Sun, which may imply that there could be water and even life on its surface. As we venture outside our solar system, we encounter a new universe of exoplanets, planets that orbit stars other than the Sun. With billions of stars in the universe, there are countless opportunities for exoplanets. Some exoplanets even wander unattached to any star, like space travelers. Among them, Proxima B stands out as a particularly striking and enticing planet. With only 112 days in its year, shorter than Earth's, and a distance to its star that is typically closer than Earth's to the Sun, one side of the planet is constantly bathed in sunlight, while the opposing side remains in perpetual darkness. Let's look at Proxima Centauri, the star around which Proxima B revolves. The Alpha Centauri system, which includes Proxima Centauri, comprises 3 stars: Rigel Centauri, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, Alpha Centauri C. These stars form the closest star system to our solar system. Alpha Centauri A and B, G, and K-type stars make a binary system that appears as a single star in the constellation Centaurus and ranks 3rd in brightness among stars in our night sky. Proxima Centauri, with less than 2.7% of the Sun's luminosity, is a red dwarf, an M-type star located approximately 0.21 light-years from the other 2 stars and 4.2 light-years from Earth. It is the closest star to our Sun. In fact, Proxima means closest in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn, it remains hidden from the naked eye with an apparent magnitude of 1113, significantly fainter than the human eye's limit of 6.5. Don't let that fool you. Red dwarfs like Proxima Centauri are a fascinating class of stars. They are among the most efficient in terms of energy generation. Although they produce less energy, their internal convection processes enable them to shine for trillions of years. Proxima Centauri will remain a main sequence star for an additional 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri remains uncertain. One challenge is that it is a flare star, prone to frequent and intense explosions. As a low-mass star, its habitable zone is much closer than the Sun's, estimated to be between 0.023 and 0.054 astronomical units. This proximity makes it less comfortable for life. Proxima B endures intense bombardment from ultraviolet light emitted by its star, far more powerful than the radiation Earth receives from the Sun. This extreme radiation can strip away even the smallest particles like hydrogen, along with oxygen and nitrogen. But that's not all. Just because a planet is in the habitable zone does not mean it can sustain life. Proxima B may lack a stable environment vital for controlling temperature and maintaining a water-friendly surface. Without such conditions, life would be susceptible to harsh space weather, making it nearly impossible. Thus, while Proxima B may appear Earth-like on the surface, it is a long way from supporting life. Scientists exercise caution, as numerous factors make it hostile. The mission to unravel Proxima B's mysteries continues, and the James Webb Telescope, launched in 2018, is a critical tool that has won astronomers' attention. With much anticipation, it will help us determine whether Proxima B is habitable. However, as with all scientific endeavors, things are never as clear as they seem. Numerous adjustments were required to ensure the James Webb Telescope accurately represents data. Abby Tabor, a theoretical physicist at Harvard, explains that a planet like Proxima B can absorb light from its star and emit it as infrared light. The James Webb Telescope was designed to detect and capture infrared light, photographing this planet's surface to look for patterns that could indicate the presence of water or an atmosphere. But what if the planet's environment makes life difficult? The presence of an atmosphere does not guarantee life. Ed Turner, an astrophysicist at Princeton University, warns that Proxima B could resemble Venus, with a dense atmosphere far thicker than Earth's and temperatures too extreme for life to exist. The journey to decipher Proxima B's mysteries is fraught with difficulties, but the James Webb Telescope holds promise. There are additional aspects to consider, including increasing pressure from space scientists to observe planets like Proxima B. The stakes are high, but the rewards are even greater. The chance to investigate the unknown and discover a distant planet's secrets that could possess life-sustaining potential is a worthwhile pursuit. If the exoplanet were habitable, might we visit it one day? As the closest exoplanet to us, Proxima B is captivating, almost like an extension of our backyard. Its near-identical size and location in the habitable zone suggest it might have life-sustaining conditions. Its proximity also makes it a perfect target for our search for life, a strong contender for future interstellar missions. We should investigate this Earth-like exoplanet, but we can't travel there yet. It remains on our radar as technology advances for future missions. One of the most exciting advancements in space exploration is the potential use of solar sails. These extremely thin sails could propel a spacecraft bound for the Alpha Centauri system, including Proxima, using solar pressure to stay on course and eliminate the issue of running out of fuel. This cutting-edge technology offers new perspectives on the possibility of life on other planets like Proxima B. However, like any ambitious endeavor, there are limitations. The existence of an atmosphere does not guarantee life. Proxima B could resemble Venus, with its intense heat and unwelcoming atmosphere. Additionally, data from the James Webb Telescope may reveal more challenges. The journey to explore Proxima B is not an easy task. It would take a spacecraft similar to Voyager 2 approximately 75,000 years to reach the Proxima Centauri system. Yet the prospect of uncovering a habitable exoplanet so close to Earth keeps it an exciting target for exploration. These emissions, if it only achieves a brightness of 5% of the current daytime side, may not appear like a lot. But when it comes to a star that is typically less bright than our own sun, it is very important. If Proxima B has advanced cultures, they could use bright orbital mirrors to reflect sunlight coming in from the daytime to the nighttime side. How cool is that? There are numerous planets waiting to be discovered in our universe. They come in a wide variety of sizes, some being enormous gas giants, whereas others resemble our own Earth. But what exactly are we aware of? One type of exoplanet that has piqued the interest of space scientists is the gas giant. The composition of these planets is comparable to Jupiter and Saturn. However, some of these massive beasts, identified as super-Jupiters, exceed even the largest planet currently in our solar system. Not only that, but there are also some hot gas giants, like Jupiter, which are extremely close to their host star. This results in a sweltering planet with temperatures that could melt metal. Imagine seeing one of these planets in close proximity, with its violent storms and gas, in addition to extreme heat. Neptunian giants are also found among exoplanets, with sizes comparable to Uranus and Neptune. These include small and hot Neptunes, which are less large and located closer to their host stars, as opposed to their gas giant relatives. These planets frequently remain mysterious, despite the difficult atmospheres, which are hard to study from afar. And please do not ignore the exoplanets that resemble Earth. These planets, similar to our own Earth, are available in sizes ranging from 2 times smaller than our planet. There are even super-Earths of this size, which have masses more than twice ours, despite being lighter than Neptune. One of the most intriguing exoplanets, Proxima Centauri B, was recently discovered. It revolves around the star of the same name. This planet is considered a super-Earth, estimated to have a mass of 7 Earth masses. Despite the fact that it is close to its host star, it is still far enough away to be considered in the zone of habitability. Proxima Centauri B is not the only one with a partner. Proxima Centauri C, which is much further away from the star, has a period of about 5 Earth years in its orbit. In 2020, it was discovered using pre-recovery Hubble data. Even more so, the Proxima Centauri system is intriguing because it seems to be an extremely bright world, possibly due to the existence of a ring system. There is more to discover within the system of Proxima Centauri. Astronomers noticed a change in 2019 in the speed of the star's orbit, which could be the result of a different planetary companion. If confirmed, this planet will be known as Proxima Centauri D and will be roughly the same size as Mars or Mercury. Imagine living in an area where the night sky is brimming with stars and countless different planets, each with its own distinct characteristics and orbits. The universe is full of unexpected discoveries, and exoplanets are one of them, with brand new findings being made on a regular basis. While we wait, you can become a space scientist. We presently lack an accurate count of exoplanets, but we do know that they exist in the same stars that illuminate them. Exoplanets, on the other hand, are frequently hidden from view by their host stars, making it difficult to study them directly. As a result of technological advancements, exoplanet imaging is now possible. For a direct image of an exoplanet, it needs to be big enough to be seen by the telescope, sufficiently far from its host star so as not to be obscured, and young enough to be hot enough to be visible from space. These restrictions limit the number of exoplanets that can be imaged directly. However, they provide an intriguing glimpse into the characteristics and components of distant worlds. Exoplanets are most frequently discovered through the modifications they instigate in their host stars. A planet's gravitational pull can make its host star sway, and by this, radial velocity can be determined. The Kepler Space Telescope, used by astronomers, utilized the transit technique, which measures a star's light dimming when an exoplanet passes in front of it. This method has given us useful information about the size, distance, and temperature of exoplanets. Here are a few amusing facts. Did you know that more than 22% of stars, including the Sun, have planets the size of Earth in their habitable zones? The place where TRAPPIST-1 is located has 7 exoplanets with water on rocky surfaces. Exoplanets with surfaces similar to those in our solar system can also exist. Examination of moon satellites shows that with more than 4,000 discovered exoplanets, we are aware that they are abundant. Hot Jupiters all over the universe are the easiest to locate because of their mass and rapid rotation, but there are numerous other exoplanets yet to be found. The James Webb Space Telescope from NASA is revealing the universe's secrets, one discovery at a time. This remarkable telescope has been gathering information and taking stunning images, revealing previously undiscovered wonders. It recently made an important discovery that will alter our perception of the universe. NASA announced that the James Webb Space Telescope discovered the first and only conclusive evidence of carbon dioxide in a planet's atmosphere outside the solar system. This discovery provides important information about the formation and composition of the planet, offering a window into the mysteries of this gas giant planet, 700 light-years away, around a sun-like star. This discovery signifies an important advancement in the search for life on other planets. NASA Administrator Bill Nelson stated that this finding offers a new way of looking at the universe, sparking excitement among astronomers and scientists throughout the world. But that's not all. The James Webb Space Telescope has been busy taking stunning pictures and collecting information about the universe. a young, light-emitting object in the infrared with the number 1104, illuminates the cool, spherical cloud behind the orange spots and material cloud, revealing starlight from far away, obscured by the ice in the cloud. The Webb's remarkable research was part of an Ice Age project that aims to investigate the genesis of ice, from its formation to the formation of icy comets. The James Webb Space Telescope has also envisioned the workings of a dusty disk in the vicinity of a red dwarf star, capturing it for the first time at these frequencies of light in the infrared. Exoplanet Proxima B is intriguing and has attracted the interest of scientists and astronomers alike. The discovery of this Earth-like planet, 4.2 light-years away, and in its own orbit in the habitable area of Proxima Centauri, has provided opportunities for future exploration and research. As we continue to investigate planets such as Proxima B, the features of modern telescopes like the James Webb Space Telescope, JWST, are becoming more and more important to unlock the unsolved mysteries of faraway worlds. The capability of the JWST to detect infrared light allows it to gather data regarding the conditions of the surface and the atmospheres of possible exoplanets like Proxima B, revealing whether these planets might be home to life, oceans, or other vital ecosystems supporting circumstances.